Welcome back to Pre-Algebra with Miss Betsy. I'm glad you're joining me, hanging in there with me as we're discussing how to multiply and divide rational numbers or multiply and divide fractions. If you're using the same text that I am, I'm using Pre-Algebra for Christian Schools. It's published by Bob Jones University Press, first edition. I'm in section 7.2 on page 222. Simply entitled Dividing Rational Numbers. Now, lame joke for today is really lame. Why didn't the dinosaur cross the road? Roads hadn't been invented yet. So, anyway, how do you divide a rational number? Well, before we can talk about dividing rational numbers, we want to talk about something that is called a reciprocal. And a reciprocal has another name that's a little bit longer, and it's called a multiplicative inverse. So what are reciprocals? Reciprocals, they are two numbers whose product is 1. What is a product? Remember, the product is the solution or the result to a multiplication problem. So if you had 3/7 times 7/3. That would be an example of a pair of reciprocals, because when you multiply those together, 3 times 7, 7 times 3, is 21 over 21, which reduces down to simply a product of 1. It's a good example. Another example of a reciprocal would be 7 times 1/7. And that's equal to 1, because if you write this whole number here as a rational number, 1/7, you see that you can cancel common factors here. A factor of 7, 1 times 1 is 1 over 1, which is 1. And you see what I did on this one here? I didn't even address the fact that you have a factor of 3 in common. You can divide the numerator and denominator by 3. You can also divide the numerator and denominator by 7. I went through the steps, multiplied it out, to verify to you that when you have reciprocals, you multiply them together and their product is always going to be 1. Now, what do you notice here? 3/7, 7/3. 7 over 1, 1 over 7. And that's right. Reciprocals are very close to the same number. You take your first number, whatever it might be, 8/23, and stand that number on its head or invert it. 23 over 8. You have a common factor of 8 that you can cancel. You have a common factor of 23 that you can cancel. And you end up with 1. So with a fraction, with a rational number, to determine what its reciprocal is, you simply stand it on its head. Now, there is some teaching involved in how you, some theory involved in what's behind the fact that causes those reciprocals to multiply together and equal 1, but I'm not going to, really not going to go there with you guys. I'm going to say that if you need to know what a reciprocal is, you take the fraction, you convert whatever your number is. If it's a whole number, you convert it into fraction form, like we had 7. If it's a mixed number, you're going to have to convert that into a fraction as well. So 2 3/7, 14 plus 3, is equal to 17 over 7. If we wanted to know what the reciprocal of 17 over 7 is, turn it on its head, and you would see that a number, 17/7, multiplied by the reciprocal of that number. You have common factors of 17, common factors of 7. You have verified for you again, illustrated for you again, that a number multiplied by its reciprocal is always equal to 1. So, reciprocal numbers are two numbers whose product is always equal to 1. That's a really important piece of information that we are going to use as we move a little bit more into dealing with pre-algebra and multiplying and dividing fractions. Now they also want you to understand, and we're going to illustrate that here on page 221, that if you multiply by the reciprocal of a number, that's the same as dividing by a number. This is an important piece of information. Write this down. Multiply by the reciprocal. The reciprocal, accept it as a C, not an S. Reciprocal is the same as dividing by the number. Same as divide So let me give you an example here. Let's say that we have 25 divided by 5. What's 25 divided by 5? 25 divided by 5 is 5. So dividing by a number, let's multiply by the reciprocal of that number. 25 multiplied by the reciprocal of 5. What is the reciprocal of 5? The reciprocal of 5 is 1/5. Is that really going to be the same thing? Well, let's think about this. How do we multiply a whole number and a rational number? Have them both take the form of a rational number, and then it becomes crystal clear and very obvious what it is that you're going to do. They now have a common factor of 5, don't they? 25 divided by 5 is 5. 5 divided by 5 is 1. We multiply numerators together. Multiply denominators together. 5 times 1 divided by 1. The answer is 5. Here, we divided 25 by 5. Over here, instead of dividing 25 by 5, we multiplied by the reciprocal of 5. We turned 5 on its head, we have 1/5. We came up with that same answer of 5, and this is what we're going to use when we're dividing rational numbers. And it's sort of like, remember when we were learning to subtract numbers or to deal with negative numbers, and we said that subtraction was the same as adding the opposite? We're seeing that to divide rational numbers, that dividing is the same as multiplying by the reciprocal, and multiply by its inverse. For rational numbers a over b and c over d, you have to have that same limiter. You can't have b, b0. You can't have d, b0. Why not? Because you cannot divide by 0. if you want to divide those two rational numbers, instead of dividing by the number, you are going to multiply that number by the reciprocal. For dividing, for example, 1/2 divided by 3/5. That is the same as 1/2 times 5/3. If we want to divide fractions, we're going to multiply by the reciprocal. We have our initial fraction here, 1/2, that we're dividing by the fraction 3/5. We want to keep that fraction, and we're going to multiply by the reciprocal. And we love to do that because when you're multiplying fractions, you multiply the numerators, multiply the denominators, and it makes our arithmetic very, very straightforward. So what we sometimes say here is that to divide fractions, we invert and multiply. Turn the second fraction on its head and multiply. In other words, we're going to take the number that we're dividing, and instead of dividing by a fraction, we're going to multiply by the inverse, or by the reciprocal. 9/10 divided by 3/4. 9/10 divided by 3/4. What are we going to do? We're going to invert the second fraction and multiply. 9/10, instead of dividing by 3/4, we're going to multiply by 4/3. Now, could we go ahead and just multiply right now and say 9 times 4, 3 times 10? Yes, we could. We would have 36/10. But is that an acceptable answer there? No, it's not, because we have common factors here. So what common factor do we have that we can reduce? 10 times 3, 9 times 4. It's interesting. 3 and 2. 2 times 3 is 6. 5th, 6 over 5. Having a hard time seeing how this is going to reduce. See, you've watched me a lot in class, and I do a lot of arithmetic in my head. See, let me explain what I was doing. I've told you I always do steps ahead, saying, okay, 36 over 10 is not going to reduce, but I've got two things going on here. 3 times 10 is not 10. 3 times 10 is 30. If we had 36 over 30, then you'd have to reduce. And you have larger numbers, so don't do that. Take the time to cancel common factors first. What do you see that you can do here that makes your problem so much easier? You say, oh, well, I can divide 9 by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. You also see that 10 and 4 can be divided by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. Now, we've done our canceling common factors before we ended up with these larger numbers here. And we have a multiplication problem. We multiply our numerators together. We multiply our denominators together. And we see that 9/10 divided by 3/4 is equal to 6/5. I'm happy with this. Don't change it to 1 1/5. How do you divide fractions? How do you divide rational numbers? You invert and multiply, or you multiply by the reciprocal of the fraction that you were going to divide. Okay? Let's go ahead and do another one. Same thing. Last video we said if you're going to multiply whole numbers and mixed numbers, you convert those to fractions first. Well, let's go ahead and do that. We have 9 divided by 2 and 7/10. 9 divided by 2 and 7/10. We're first going to write these as rational numbers. Whoops. 9/1 divided by 27/10. Both of these are rational numbers. Now in order to divide, we multiply by the reciprocal. Do we have any common factors here? Sure we do. 9 divided by 3 is 3. 27 divided by 3 is 9. Do we have anything else going on? (27/10). 27/10. Am I done? 3 and 9. See? 3 divided by 3 is 1. 9 divided by 3 is 3. Now we have 1 times 10 divided by 1 times 3, or 10/3 is our answer. I divided by 3 twice. I could have divided by 9, but let's just reverse this just a little bit and see what might have happened here if I had done something a little bit differently. What if I had said 9 divided by 1 times 10 divided by 27, simply divide by 3. 3 times 10, 1 times 9. Multiply the numerators and the denominators, and I come up with 30/9. Am I going to accept that answer from you? No, you give that to me in a test and it's half wrong, and the reason for that is that you haven't reduced this to lowest terms. So hopefully you would see at this point that both of these numbers, the numerator and the denominator, are both divisible by 3, and you would go ahead and say, oh, I missed something. And that becomes 10/3. So what this illustrates for you is whether you don't do any reducing of common factors and you end up with large numerator, large denominator, whether you cancel all of the common denominators first, or whether you get some of them and still have to reduce, you must have your answer given to you in lowest terms before you have reached your final answer. That's all that's involved in dividing, and I'll see you next time.